Lesson 6.2, solving quadratic equations by graphing. Now if we're going to solve something by graphing, there's two basic ways. One is we can go ahead and use a graphing calculator, if you have one handy, or else to do it by hand. The first thing I'm going to show you is how to do it by hand, and then we can use our calculators more. If we graph it by hand, the first thing we're going to want to know is where is the line of symmetry. And the equation we use for line of symmetry is x equals negative b over 2a, where the coefficient of x squared is a, in this case it's 1, the coefficient of x, in this case, is negative 3, that would be b, and the constant would be c. That's the term without a variable. Now, as we mentioned before, there's a couple of nice things we can tell by looking at this. We know that since a is 1, it's going to open up. We know the constant, or the y-intercept in this case, is negative 4. But if we're going to graph it by hand, we probably are going to want to have an xy table so we can plot some points. And to be efficient, the first thing we're going to want to do is, where does our parabola center around? And that's where the line of symmetry comes into play. We know that the line of symmetry goes right down the middle of it. So with those values, let's find out what the line of symmetry is. It's negative b, or opposite of b, over 2 times a. And that would give us 3/2. So we have basically a line that is going at 1.5, a vertical line at 1.5. And everything else evolves around that. So when we go and make our table, we can plug in a 0 for x, a 1, a 2, 3, and that kind of is has a couple of terms or values for x on either side of it. Plug in a 0 for x, we'll get the y-intercept, negative 4. You plug in 1 for x, you get 1 squared minus 3 times 1 minus 4, which will be, I believe, negative 6. Oops. If you plug in a 2, I believe we get a negative 6 also. Plug in a 3, you should get a 4. And again, just plugging in the values. For example, up here again, I plug in a 3, I get 3 squared minus 3 times 3 minus 4, which gives us 9 minus 9 minus 4. And that cancels out, and I believe that's a negative 4, it looks like. Oops, okay, negative 4. Glad I got that. Now if we graph those points, we have 0 at negative 4, which is the y-intercept. 1 is at negative 6. 2 is at negative 6. And 3 is negative 4. Now that should make sense because the line of symmetry should go right down the middle, and if we have a point on one side, it should mirror the distance to the other side. So we have a parabola going like this. Now, I don't have the vertex on there, my graph doesn't go low enough, but let's plug in one more thing. Let's plug in a negative 1 and a 4, so we'll go one more either direction. If you plug in a negative 1, we will get a 0. If we plug in a 4, we're going to get a 0. And by this, then, we know that our solutions are those coordinates. X of -1 and X of 4. This is a nice graph because it works out that the coordinates for the intercepts are at integers, and we have a nice simple answer. Now if you look again at the last page, we have two solutions. We have two intersection points. Now we're asked to see what one real solution looks like. So just for a quick moment, I'm going to draw out something. 3 scenarios. If you have two solutions, you will have two intersection points. If you have one solution, the vertex will be on the x-axis because it only intersects the axes at one point. If you have no solutions, the graph of the parabola does not touch the x-axis. So in this case now, where we're talking about having one real solution, it's going to look something like this. Now I put it in the first quadrant. That's not guaranteed. So we add 4 to both sides, set equal to 0. Okay, now when it is in this form again, we can go ahead and find out what A, B, and C are. Again, we know right away from the beginning that it will open up because A is 1, it's positive. B is -4, and C is 4, which means we also know the y-intercept. There's the y-intercept. Let's find the line of symmetry. -b, in this case it's -4, over 2 times A, and we get 2. So our line has our parabola has a line of symmetry at 2. So we plug some points in, and we have, again, a 0, which gives us the y-intercept. Plug in a 1, 2, 3, and 4. If we plug in a 0, we'll get the y-intercept. Plug in a 1, we'll get a 1. Plug in a 2, we'll get a 0, a 3, a 1, and 4, a 4. Again, how am I getting this? I'm going to check this one just to show you how I did that. We'll plug in a 2. I'm just plugging a 2 in for x. We're going to see what we get. We get 4 minus 8 plus 4, and that's going to be 0. So if we plot these points, 1 is 1, 2 is 0, 3 is 1, and 4 is 4. So you can see the symmetry. We also have the vertex, and that is the solution. So 2 is considered our solution. I'm going to stop here, and I'll have part B for our last part of this lesson.